Now, let's talk about how to identify linear functions. Now, we have talked about linear equations early on in this chapter. Now, we are talking about linear functions. Now, basically, linear equations, except for the vertical lines, because as we know, with vertical lines, the same x value has many different y values. So all linear equations except vertical lines are defined as linear functions. Now, if you remember, a linear function a linear equation, as we had talked earlier, is represented by the equation y equals mx plus b, which is your slope-intercept form. Now, when you're writing linear equations as functions, what you do is replace your y with f of x, and you will end up with f of x equals mx plus b for your real numbers m and b, and these will be your linear functions. Okay? So again, remember, any function that can be defined by the equation f of x equals mx plus b, where m and b are both real numbers, will be a linear function. And again, remember, it's the same thing as linear equations. Your m will give you the slope of the line, and your constant b is part of your y-intercept. So 0b will represent your y-intercept. So it's the exact same thing as linear equations. Right, so let's look at an example here, working with a linear function. And we have we're trying to graph this linear function, and after graphing it, we want to find its domain and its range. Okay, so your linear function is f of x equals negative 2x plus 5. Now again, remember, this is your slope, the negative 2, and 5 is part of your y-intercept. So starting out with our coordinate plane here, okay, let's see, our slope is negative 2 and 0, 5 is our y-intercept. Okay, so we start out by using the y-intercept as our starting point, right there. Okay, that's our 5, 3, 1, let's say. And then our slope is negative 2. Now you guys remember, when we said you have a negative 2 slope, you go in the opposite direction. So we will go down 2 units and then go over 1 unit. Go down 2 units and go over 1 unit right there. And then using these points, we can go ahead and draw a straight line through these points. And this line here represents the linear function, negative 2x plus 5. Okay, so it's the same thing that we did with linear equations. Now, the only difference is we're calling it a function. Okay, so we've done with the graphing. Now what we want to do is find its domain and find its range. So think about this. This line is going to grow in both directions. Both the ends are going to keep growing. So that tells me it's going to cover all the values on my x-axis. So again, I can say my domain is negative infinity to infinity. And same thing will happen with your range here, your y-axis. As the line keeps growing, it will cover all the values on the y-axis, and the range also will be all real numbers, which will be negative infinity to positive infinity. And this is true for all linear functions. All linear functions will have a straight line for a graph, and their domain and range will be negative infinity to positive infinity. But there is an exception to a linear function. Let's talk about that. You can have a linear function which will be defined by this equation here. Okay? And when you have f of x equals b, which is the same thing as y equals b, you know that graphs for these equations is a horizontal line. And horizontal lines are functions, because you can draw a vertical line through a horizontal line, do your vertical line test, and it will cross the line at only one point, so we know these are functions. And horizontal lines, those linear functions, are sometimes called a constant function. So you may sometimes hear these functions being called as constant functions, and that's only when you have a horizontal line as your graph for your linear function. So for a horizontal line, your domain and range, well, the domain will still be the same, but the range will be affected. So let's go ahead and look at that. Now, as I was telling you earlier, the domain of any linear function, and that includes constant functions, of any linear function is going to be all real numbers, which is negative infinity to infinity. Now, the range of a non-constant function, now when I say non-constant function, that will be all linear functions whose graphs are not horizontal lines. The range of such functions is going to be all real numbers, while, and you can guess, the range of a constant function of a constant function will be just one number, and that number will be defined by the equation itself. So whatever this number b here is, that's what your range for that function is going to be, because when you're talking about a horizontal line, that crosses the y-axis at only one point, and it's just a horizontal line, it's not an oblique line, so you will have only one number as your range for a constant function or a linear function that is a horizontal line. Right, that concludes our discussion on Chapter 7.